Now we've completed importing our pressures and rates. We've synchronized our rates to our pressures. And we've entered in all of our PVT properties and done some filtering. We're ready to move on to a diagnostic analysis. So we're going to select diagnostic analysis here. And this example is a vertical wellbore. And we have a couple more pieces of information. The pay zone thickness, which is 50 feet. And you'll notice right now we have it in meters for our units. And we can toggle between units, feet and meters here, by clicking on the little ruler button here at the top. So we had a 50-foot pay zone thickness and 8% porosity. So next we're asked to select the flow period we wish to analyze. You can see here the grayed out section of our history plot is the data that's been automatically selected. We're going to be analyzing our final buildup, but if we wanted to take a look at the drawdown, we can do that by selecting the flow period button and then clicking on the data chart. So we're going to go ahead and reselect that buildup and go to the next step, where we're actually going to perform the analysis. So let's take a look at a bigger version of our derivative plot. Now, as you can see here, we did do some filtering, which cleaned up a little bit of our derivative, but there's still a lot of scatter. So one tool that we have available to us is the derivative method that we're using to calculate. We default to the Bourdet method and we use a 0.01 sized window for the calculation, but we can get rid of some of that scatter by making that window size a little bit bigger. So you can see how that cleaned it up quite a bit, and we can see our characteristic derivative shape that we're looking for. So now we can start placing our analysis lines. They're listed for us in our perform analysis box in the order we expect to see them in our analysis, and their characteristic slopes are here in brackets as well. So first we're going to go ahead and identify that first wellbore storage period. Next, it looks like we get into some well-defined radial flow. So we'll select the radial flow line. And finally, it looks like we get into some linear channel flow. And you'll notice that we actually have the ability to calculate an estimate for that channel width by inputting our initial estimate for permeability that we got from our radial line. And then it'll give us that initial channel width estimate. Another tool that we have available to us is to put an annotation arrow on a point of interest in our derivative. Right-clicking our mouse button will give us all of the options available to us for that annotation box, and near the bottom we have the radius of investigation, which, if we enter in our initial estimate for permeability once again, we can get an idea for where we run into the first part of our boundary. So it looks like about halfway between that channel of 2,400 feet is where our wellbore is located. So now that we've put on all of our analysis lines and gotten some initial estimates for the parameters we're interested in, we can move on to creating a model.